Hello, this is 5.4 Logarithm Word Problems. Now make sure that you take note of things that you see that are important as well as things that you hear that are important. And please write down any questions you have and bring them to class. Now, logarithms are used to model several things in the real world. One of them is levels of acid, or the acidity model. Now, you may know this as a measure of pH. pH is a measure of the hydrogen ions in moles of hydrogen per liter. Now, here's the equation. pH, or the acidity level, is equal to negative log of H plus, where H plus is the moles of hydrogen per liter. Now here's a table that shows you some of the acidity levels of various things that you might be familiar with. On this slide, it's very important to note that this is the acidity level, and to note this formula, and to note what these things are. pH is acidity level, and H plus is the moles of hydrogen per liter. The hydrogen ion concentration in moles of hydrogen per liter. Now pause now and make sure you have those important things written down. Now we're going to do two examples of how someone might measure the acidity level in real life. Now for most jobs now you have to give a urine sample for drug tests. Now suppose a person gave a urine sample and it was found to have a pH level of 5.7. What was that H plus, or the hydrogen ion concentration? Alright, so let's take a look. First, we're going to start by writing down that formula. That's always a good place to start. And then we're going to substitute the values in that we were given. Well, we were given the pH level, so we substitute 5.7 in for that. And now we're going to solve for H plus. To do that, we need to isolate the log on the right side of the equation. We will divide both sides by -1. That gives us negative 5.7 is equal to log of H plus. Then we'll find the inverse of that, noting that log, when no base appears, is log base 10. So the inverse of that is 10 to the negative 5.7 power. That is H plus. Now we were asked to write that in scientific notation and round it to the nearest thousands. So I do that here. H plus is 1.995 times 10 to the negative 6. And I also want you to get into the habit of writing your answer out in words. The hydrogen ion concentration is 1.995 minus 10 to the 6. Now pause now and write down this example. Our next example of pH levels is apple juice, something that you might drink from time to time. Now, this time, we are given H plus. It is 0.003, and we're asked to find the pH value and determine the pH level of this juice. So to do that, we're going to write down our equation. pH is equal to negative log of H plus. Then we're going to substitute in what we've been given, the H plus value of 0.0003. And we're going to solve for the pH level, which is 3.5. So apple juice is acidic. Its pH level is 3.5. Pause now and copy down this example. Logarithms are also used to measure the volume of sound. Now in this formula, L, the volume of sound is measured in decibels. So this is a measure of decibels. Now you probably already know that decibel is a measure of sound. But if you look at this equation, you see that L is the volume of sound, and I is the intensity of that sound in watts per square meter. Now, anything over 85 decibels can cause hearing damage or hearing loss. So, it's not important that you write down everything in this figure, but it is important that you note this formula and that you document L and I. Now, pause now and write down the important things on this slide. Our example for decibel levels or sound is a gunshot from a rimfire rifle, and it has an intensity I of 2.5 times 10 to the 13th power. Now, the question is, should you follow the rules and wear ear protection while you're shooting this rifle at the rifle range? And I want you to round your answer to the nearest decibel. So let's take a look. First, as always, we're going to write down the formula we're going to use. Then we're going to substitute in what we've been given. We've been given I as 2.5 times 10 to the 13th. So we're going to write that here. And now we're going to put this whole thing on the right side of the equation in our calculators. And we will determine that L, or the volume of sound, is 264. That's way over the safe level of 85 decibels. So yes, we definitely should wear ear protection. Pause now and write down this example. Our next example in the area of sound is a Boeing 747 jetliner. Now those are pretty loud, and it produces a loudness level of 113 decibels. This time we're going to find I. So let's write down our formula. And we've been given L, the loudness, 113. So we substitute that in and begin to solve for I. To do that, we need to isolate this log expression here. So our first step is to divide both sides by 10. And then we are going to expand this log expression into two different logarithms. The quotient rule of logs says that if I have a log whose input is division, I can break that up into two logarithms, one subtracted from the other. And so I'm going to do that here, and I end up with log of I minus log of 10 to the negative 12. Now that I have that, I'm going to add log of 10 to the negative 12th to both sides. And I'm going to note that if there is no base written, it is base 10. And now I'm going to solve for I. I is 10 to the 11.3 power plus log 10 to the negative 12 power. You may have questions on how I solve for I there. If so, I want you to go back and look at the first or second slide of log properties, or bring that question to class. And we find out that I is 1.995 times 10 to the 12th power. Pause now and write down this example, along with any questions you may have on how we got from this step to this step. Now the third use of logarithms that's famous is the Richter scale model. Now here's the equation. M is equal to 2/3 log times E divided by 10 to the 11.8 power, where M is the magnitude of an earthquake and E is the energy released by the earthquake. When we say an earthquake measured 4 on the Richter scale, we're talking about the magnitude, not the energy released, the magnitude. So again, not important that you note this. However, you should note that each level is 10 times stronger than the previous level. 10 times. So let's take a look at an example, and I think you'll see how much energy is released by an earthquake is enormous. Now, a long time ago, early in the century, actually early in the last century, there was an earthquake in San Francisco, and it measured 8.3 on the Richter scale. That same year, there was another earthquake that was recorded in South America that was 4 times stronger. What was the magnitude of the earthquake in South America? Pardon my typo there. Now, we're going to have to back into answering the question of the magnitude of the South American earthquake by first discovering how much energy was released by the San Francisco earthquake. So let me show you what I mean. Here's the formula that we will use. Let's plug in what we know. We know that the San Francisco earthquake had a magnitude of 8.3. So let's solve for E and see what happens. Well, to solve for E, we need to isolate that log expression. So we're going to divide both sides by 2 over 3, which ends up being the same as multiplying 8.3 by 3 over 2. And then we are going to separate or expand this single logarithm into 2 logs, because log base 10 of 10 to the 11.8 power is a number. And now we can add that to both sides of our equation and isolate the log of E, where E is our unknown or our variable. And so we find out that log base 10 of E is equal to 24.25. Okay, from there we solve for E, and we will find out that E is equal to 10 to the 24.25 power. Now, how did I find that? I took the inverse of this expression. E is equal to 10 to the 24.25 power. Now that I know that, I'm going to write it in scientific notation, which is 1.778 times 10 to the 24. And I'm going to take the energy released by the San Francisco earthquake and multiply that by 4. Why? Because the South American earthquake was 4 times stronger. So I'm going to multiply this by 4, and I get 7.113 times 10 to the 24th power. Now that I have E for the South American earthquake, I can plug it in and solve for M. I will conclude that the South American earthquake had a magnitude of 8.7, which was 4 times stronger than the San Francisco earthquake. Now pause now. Write down this example, and especially write down any questions you have about how we solve this problem. This is an important problem for you to know how to solve. Our last model is the wind speed model. Now, if we know the speed of the wind, we can tell how far d in distance the tornado will travel. Or if we know how far the tornado traveled, then we know the speed of the wind. Now, I'm sorry. I want you to make sure that you have this model written down and named the wind speed model, and that you have documented what S and D are. In March of 1925, there was a tornado whose wind speed was about 280 miles. Now, we want to know, how far did that tornado travel? Now, we're going to note our formula. S is equal to 93 times log of the distance plus 65. Now, we were given S, so let's plug that in and begin to solve for D. So, it's 280 is equal to our formula. We're going to subtract 65 from both sides. We're going to divide both sides by 93. And now we're going to note that this is log base 10. And we're going to take the inverse of that equation, that log function right now, and we end up with 10 to the 215 over 93 power is equal to D. That makes D equal to 205 miles. That earthquake traveled 205 miles. Pause now and write down this example and any questions you have and bring them to class. Thank you. That's the end of this video.